Okay, let's start with the integration. This subtopic is known as integration by parts. Okay. See, definition of integration. What is the definition of integration? If I differentiate a function a and get the answer as b, then integral of b dx is a. For example, I differentiated x cube and got the answer as 3x square. Then what I can say, integral of 3x square dx is x cube. This is a definition of integration. So whenever we ask you what is the definition of integration, this is what you have to say. Derivative of a function f of x. You got g of x as answer. Then integral of g of x. Derivative is done with respect to x. So dx comes over here, equal to f of x. This is a basic definition of integration. Now today I am going to teach you integration by parts. To prove the theorem, integration by parts, I need this basic definition. So let's have a look at the proof theorem. So heading is integration by parts. Integration by parts.
सर वो पहले वाला लिखना था क्या?
It's up to you. Now integral of u into v dx. Product of two functions. U into integral v dx minus integral of derivative of u integral of v all into dx. It looks very complicated, but I'll make you learn this in few steps. But at present, my aim is to teach you how to prove this theorem. And proof of this theorem is a common question in the board exam. Every time they ask this proof. You can say alternate every month, you can every year you can see the proof being asked. First I'm going to give you the steps to do it. Very small step. If you can recollect these steps, it is very easy to do. What you have to do first is take this first term and differentiate it. You will get some answer. Then you use the idea integral of b dx is a. So only thing that you have to remember is what to differentiate. Out of these three terms, which to differentiate. This term you should take it and differentiate. That's it. But differentiating like this becomes a little difficult. So what you do is integral v dx, you call it as w. And then differentiate uw. Then differentiate uw. We know how to differentiate uw, right? So what will be the derivative of uw? Derivative of uw will be u into derivative of w plus w into derivative of u. So derivative of a is b. So what's your conclusion? Integral of b is a. So u dw by dx plus w into du by dx whole into dx is uw. In fact, your proof is completed with this. Only you have to remove these w's. And what is it w known as? Integral v dx is w. So wherever w is there, you can replace by integral v dx. And wherever derivative of w is there, so integral of v dx is w implies derivative of w should be v. Which means this will be replaced by v. This will be replaced by v. This will be replaced by, this will be replaced by integral w v dx. And this also will be replaced by integral v dx. And with that, you get your answer. So do they understand the technique? Once again, tell me the technique. Take the first term of the right hand side. Differentiate it with respect to x. Then apply the definition of integration and remove the w, you get the answer. So let's have a look at, now I'm going to teach you the whole method. So first I give you the idea behind how to do it. So what is the point to remember? When you see this theorem in your mind, what should you remember first? You need to differentiate the first term of the right hand side and apply the definition of integration. So I'll start like this. So proof starts from here. Let integral v dx equal to w. Then derivative of w with respect to x equal to v. This is your equation number 1. Then I start with consider. What I'm considering, d by dx of derivative of the first term, u w, which is u into derivative of w plus w into derivative of u. Then what I can say? Then by definition of integration, what I can say? Integral of the right hand side. Integral of the right hand side. Integration's derivative is done with respect to x, so dx will come here. Is uw. Everybody understood this particular step? It is what I explained in the previous year. Derivative of f of x is g of x, then integral of g of x is f of x. That's what I applied here. Now what I should do after this? Separate it. U dw by dx into dx plus integral w into du by dx into dx is uw. Is it okay? Okay, then what I should do? Wherever dw by dx is present, replace it by v. Wherever w is present, replace it by integral v dx, and you will get your answer. That's it in it. So I'm going to do that. I don't have space here, so I'll write it here. Integral u v dx plus integral v dx into du by dx whole into dx is u integral v dx. So now what I've done, this is your left hand side, this is your right hand side second term, and this is your first term of right hand side. So from here I can say integral u v dx, integral u v dx is equal to, so your left hand side is u integral v dx minus integral of v dx into du by dx whole into dx. Is this clear? Is it clear to you?
Yes, sir.
Yeah, I'll do. Okay. Now what I have written here is integral u v dx is u into integral v dx minus integral of derivative of u. In the proof, derivative of u became second. That doesn't matter. To remember this formula, to apply this formula, I'm going to teach a shortcut. Phys minus integral dphys. Can you remember this much? Phys minus integral dphys. Whenever you see this integral uv, remember this, phys minus integral dphys. Phys means, f means first function. First function. Is means integral of second. Df means derivative first. First, that's all to remember. Imagine I want to integrate x sin x. So I will take x as first, sin x as second. I am going to apply this formula. First function, what should I do with first function? Write it as it is, don't integrate it. Integral of second, second is sin x, so integral sin x dx. minus integral of product of two terms. What are the two terms? Derivative of the first, integral of second, whole into dx. Why this dx? Why this dx? This integral sign has one dx. This integral sign has another dx. So your answer became x into integral of sin x became minus cos x, minus integral of derivative of x became 1. Integral of sin x became minus cos x. So this became minus x cos x plus integral of cos x became sin x plus the integral constant. So integral constant will be written only after everything is completed. Don't write in between integral constant. Then your system will go wrong. This is a whole process. That's why we call integration by parts. Parts by parts you have to integrate. That's why we call integration by parts. But the integral constant should be written only in the last step. After all the integrals are completed. Is it clear to you? Now I want to check my answer is correct or wrong. How do I check integration answer is correct or wrong? If I differentiate this function, I should come back to the question. So let's have a look at it. Suppose I differentiate minus x cos x plus sin x plus c also. Sin x plus c. Naturally, this I have to apply product rule. So minus x into derivative of cos x, that become minus sin x, plus cos x into derivative of minus x, so minus 1, plus derivative of sin x. And derivative of constant is 0, so I am not written. Derivative of sin x is cos x. So this and this will get cancelled, and you will end up in x sin x as answer. So in fact, it is a product rule reversion. That's why it is having two parts. Here you applied the product rule. The term which you don't want, it get cancelled by it. So that is exactly you have in these two parts. Now my question to you is, can I interchange the position? In this method, I took sin x as a second function. Can I take sin x first and x as a second? So is this possible? So what you'll do? If they say take this as first and this as second, it will be first into integral of second, integral of x dx, minus integral of derivative of sin x, I'm writing directly cos x, into integral x dx, whole into dx. What happens here is sin x into x square by 2 minus cos x into x square by 2. What is happening? This is not getting terminated. What happened here? When I differentiated x, it became 1. And you had only a just single term to integrate. But here again we have a product term to integrate. So we cannot end this. This process will continue. It will never end. So it is important for us to know which function should I take first and which function should I take second. So that is by this order. Look at this. L, I, A, T, E. In your 12th standard syllabus, if you take in this order, you will get all your answers correct. But you may learn in engineering, ILET you will be using this. IALTE. So in 12th standard, you follow LIATE. In later on, you may change this, but this does not matter. As long as the problem works out, you can use this order. L stands for log, I stands for inverse trigonometric ratio, A stands for algebraic, T stands for trigonometric, and D stands for exponential. So for as far as 12th standard is concerned, you can go by this order. But IALTE, that is also is applied in engineering. Okay, so that does not matter. Whichever is better for you, you can apply that. But always it does not work. Suppose I ask you to integrate x log x. So in your order, log comes first. And algebraic, x means algebraic means what? X, x square, x cube, these are algebraic. Inverse trigonometric function. What is inverse trigonometric function? Sine inverse, cos inverse, tan inverse, etc. Trigonometric function, what is it? Sin x, cos x, tan x. Exponential, what it is? e raised to x, 2 raised to x, all those things. So if I have x log x, what are the two things I have? I have logarithmic and algebraic. Logarithmic is before algebraic, so I start with the logarithmic. So first function into integral of second minus integral of derivative of first into integral of second all into dx. So your answer became log x, integral of x is x squared by 2 minus derivative of log x 1 by x, integral of x x squared by 2 into dx. So I can write this as x squared log x divided by 2 minus 1 by 2 into 1x will get cancelled, so it became x dx. So it became x square log x by 2 minus 1 by 2 into x square by 2 plus 6. So my final answer is x square I can take common, by 2 I can take common. So I can write log x minus half plus 6. This becomes my answer. Is it clear to you, all of you? Is this first part clear?
Yes, sir.